The air then distributes into the rooms or zones by flowing through each of the branches. The air then flows through these diffusers and distributes across out into the room. On the other side of the room, we have the return grill. This collects the dirty air and sends it back to the main AHU. On each supply branch, we will find one of these units. This is the VAV terminal. This is one of the main differences between a VAV and a CAV system. Each VAV terminal serves a certain zone. Within the zone, we will find a thermostat. This is usually mounted on the wall with a cable running from this all the way back to the VAV terminal. The thermostat tells the VAV terminal whether the temperature of the room is too hot, too cold, or just right. The VAV box will look something like this. There's an inlet, which is where the air enters from the branch and supply duct. Then we have the main VAV box, and then we have the exit where the air leaves and supplies the zone. Looking inside the VAV terminal, you can see it's a fairly simple design. There's nothing too complex happening inside these. On the side, we usually find a controller, which is mounted onto the actuator. The actuator controls and rotates the shaft. Connected to the shaft is a damper. The damper is basically a sheet of metal. The damper can modulate its position to cover or uncover the inlet. This blocks the stream of air or allows it to flow, which therefore controls the flow of air into the unit and thus into the zone. When the room is too hot, the thermostat tells the controller to unblock the inlet and let more cold air in. When the room is too cold, the thermostat tells the controller to start partially blocking the inlet to prevent more cold air entering. The air entering the terminal is typically around 13 degrees Celsius or 55 degrees Fahrenheit, although this temperature can be adjusted via the BMS system or control panel on the AHU.